In this next question, we're asked which beaker has the highest average kinetic energy. Now recall from earlier that the average kinetic energy is exactly equal to the temperature. So here they're simply asking which beaker has the highest temperature. Notice that they also are including volumes here. Volumes have nothing to do with temperature. So the highest temperature here is 30 degrees. The next question asks, which structural formula represents polar molecule? When we're looking for a polar molecule, we want to look for asymmetry. So when we look at how these structures are drawn, we can see that choice A lacks horizontal symmetry. It has some vertical symmetry, but horizontal symmetry it lacks, versus choice B has both horizontal and vertical symmetry, as does C and D. So the one that lacks symmetry is a polar molecule. Question number 29 refers to a methane molecule. Now, methane molecule, carbon is the center because it is the lone atom. It has no subscript. And carbon has a valence of 4, so we'll place its valence electrons. And then it will bond to hydrogen, which has a valence of 1, in this way. So we're left with this symmetrical shape. And they're asking, well, what is the shape? So whenever we have this shape, it has 4 corners. And 4, the prefix for 4, is tetra. So that's called a tetrahedron. The next question asks about a molecule of hydrogen chloride. We have several key words here. The word molecule is synonymous with covalent bond, so we can immediately eliminate ionic bonds. Now, hydrogen chloride is HCl. If we want to know the type of bonding present, we can use subtraction of electronegativity values. Recall that in nonpolar covalent bonds, the difference of electronegativity must be 0. The only way to have a 0 difference of electronegativity is to have the same molecule bonded to itself. So this is not a polar covalent bond. This is indeed a polar covalent bond. Now, hydrogen bonds are bonds between hydrogen and fluorine, oxygen, and nitrogen. So it couldn't be hydrogen bonds either. Question 31 asks, electrons in a bond shared between 2 iodine molecules. So iodine, it's bonded to itself, so its electronegativity difference would be 0. And since its electronegativity difference would be 0, we would have a nonpolar covalent bond. When we have a nonpolar covalent bond, electrons are shared equally because both atoms have equal strength for attracting electrons. Question 32 asks us to describe a substance with a low melting point and poor electrical conductivity. Low melting point and poor electrical conductivity represent covalent molecules, which are only made up of nonmetals. And recall that covalent is synonymous with molecule. Question number 34 asks for a crystalline solid with a high melting point and a good conductor of heat in the liquid state. This represents an ionic bond. Now, ionic bonds are between metals and nonmetals. Question 34 asks about the bonds between barium oxide. Barium is a metal, while oxygen is a nonmetal. Metals and nonmetals, different sides of the periodic table, are ionic bonds. And ionic bonds transfer their electrons. Question number 35 asks which has the highest melting point. Notice that all these formulas are hydrocarbon formulas, so this is not related to the type of bonding. Since carbon and hydrogen are both nonmetals, all of these substances have covalent bonds. The difference is the number of carbon and hydrogens. Recall, the larger the molecule, the more the intermolecular force, the van der Waals force. So the highest melting point will be choice D because it has the most mass, the most atoms, the most van der Waals intermolecular forces.